Good morning and welcome back. So on the last video we talked about congruent parts of different figures and how if the parts are congruent then the figures are also going to be congruent. Or maybe they were triangles, and that's what we're specifically going to get into is the congruence of triangles. So we know that if we have bell just rang here. We know that if we have two triangles, okay, and we know that all of the sides are congruent, or the corresponding sides are congruent, right? Then we know that those triangles are going to be congruent. But here's the thing. We don't need all of that. We don't need to know all three of the sides of a triangle and all three of the angles to know that the two triangles are congruent. And that's what we're about to jump into with the triangle congruence theorems. So there are a few theorems, 4 that we're specifically going to talk about, that if you know these parts, these corresponding parts are congruent, then you will know that both of the triangles are exactly the same. So let's go ahead and jump in. So the first one we're going to talk about, and you'll always know based upon its lettering, is ASA. Okay? ASA stands for, is an acronym for angle, side, angle. Angle, side, angle, triangle congruence theorem, which basically just says, and I'm going to draw some new triangles. The angle, side, angle, triangle congruence theorem says that if two angles and the included side, what it means by included is that it's inside. It's in between the two angles that we're talking about. Of one triangle are going to be congruent to two angles and the included side of another triangle. In that case, if you have those, if the two angles and the included side of both of the triangles are congruent to one another, then the triangles are going to be congruent. Let me just show you what that means. So if we have two triangles, okay, and I tell you that this angle is congruent to this angle, and then I tell you that these angles are congruent to one another. Again, they're corresponding. And then there's an included side on both of them, so a side that is in between both of those angles that are congruent, then these two triangles are going to be congruent. So I'm going to do an example with you, and then I'm going to give you an example that you can do on your own. So in this figure, and this is how you will always know what is congruent to what just based off of a picture. So in the figure, it tells me that angle R is congruent to angle R is congruent to angle X. And that is shown by this little line in the angle. Okay? So those two angles are congruent and they are corresponding. They're corresponding to one another. And we learned about corresponding angles and sides in the last section. And then it tells me that angle T is congruent to angle Z. That's why there are two lines there. And now we have that RT is going to be congruent to XZ. So those corresponding sides are congruent, and it's shown by that line that goes on the side. So therefore, we have an angle, okay, a side that is included, and another angle. So we have ASA. So therefore, these two triangles are going to be congruent to one another. So we can say that RST, the triangle, is going to be congruent to triangle XYZ. We can't just say that they're congruent. How did we know that? Well, they're congruent by the angle, side, angle, triangle congruence theorem. And that's really all there is to that. When you understand that you only have to have 3 parts in a certain order to know that 2 triangles are going to be congruent, it's going to make determining if triangles are congruent a lot easier. So at this moment, I want you to freeze this video, or freeze. Oh God, such a millennial. Okay, if I say to pause this video, I would like for you to go ahead and work on this example. Okay, so hopefully at this point you've already worked on this yourself. But now what I'm going to do is I'm going to solve them. If B and E are both right angles, okay, so we know that they're both right angles and they're corresponding. And BC is congruent to EF. So I need a different color. So BC is congruent to EF. What else must be true to say that these 2 triangles are congruent by ASA? So we have an angle here. We have an angle. We have a side that is congruent. Now we need something else. So you may have said that we need angle C and angle F to be congruent. So to answer this question, what else would needs to be true? So angle C needs to be congruent to angle F in order for them to be the triangles to be congruent by ASA. Okay? And let's do the next example. So then it says that if B and E are both right angles, so again, we know that, and angle D is congruent to angle A, what else might need to be true in order for these 2 triangles to be congruent? Well, we have this angle, right? And then we have another angle that we know are congruent. What else do we need in order to prove ASA? So you may be saying that we need that included side. So we would need side AB, to be congruent to side DE. Those sides would need to be congruent in order to prove ASA. Okay, so that concludes our angle-side-angle congruence theorem. So now moving into the rest of them should be pretty easy. So now we have SAS, which, as you can probably already assume, is side, angle, side. Okay, which means if 2 sides and the included angle, so now it's the opposite. It is no longer angle, side, angle, where the side is included. Now the angle is included. In that case, the triangles will be congruent. So let's try an example. So it tells us here that RT is congruent to LN. RT congruent to LN. So we have a side. Okay. Now it tells me RS is congruent to, and if you look, it has 2 little lines here telling you that those 2 sides are congruent. So RS is congruent to LM, and then angle R is congruent to angle L, shown by that little green line. Therefore, so now we have a side, an angle that is included, and another side. So now these 2 triangles, triangle RST is going to be congruent to triangle LMN by the congruence theorem SAS. Okay? So these will get really self-explanatory. You'll notice that the lettering totally represents what you're looking for. So pause this example for a moment, and I want you to try working on it yourself. Okay, so at this point you should have already worked this problem, but I'm going to go ahead and work it out as well. So using the figure, fill in the missing information needed in order for these to be congruent. Okay, so if we're proving SAS, we are going to need a side that is congruent, which we have the first side. It tells us that both of those are 12 centimeters. And then we have an angle here, but we don't know what y is. But in order for them to be congruent by SAS, those two angles would need to be congruent. And then lastly, the side here at the bottom would need to be congruent to the 5 centimeter side in order for these to be congruent triangles. So in order to have side, angle, side, y would need to be the same as 90, and x would need to be the same as 5 centimeters. So now these two would be congruent. This would be 90, so those would be congruent. And then x would be 5 centimeters, so that those two bottom sides are congruent. So now we have SAS, side, angle, side. All right, now you have the opportunity that you can work on the practice portion that is on Schoology as well, and then that should be it.